Hello, my name is Travis Reeder. I'm an architect at Oracle, and today I'm going to talk about the FN project, the open source cloud agnostic serverless platform. So let's start off with a little background. What exactly is serverless? Serverless is an abstraction of infrastructure and its operations, including provisioning, scaling, patching, management, etc. Serverless architecture is when you build an application entirely on serverless components, being compute, storage, networking, the main things. Functions as a service, or FaaS, is the compute component in a serverless architecture. And that's what we're going to focus on today. The FN project is the compute side of serverless. So what is a function? In mathematics, a function is a relation between a set of inputs and a set of outputs, with the property that each input is related to exactly one output. Functions in a FaaS are very similar. You write a small bit of code, it accepts input, does some small thing, and then produces some output. As a service means you can host these functions, typically in the cloud, so they're accessible anywhere. The system takes care of the provisioning, scaling, and management of that function, and each function can scale independently. What about microservices? It wasn't too long ago that microservices were the hottest thing. 5 years ago, everybody's talking about moving from monoliths to microservices. And that movement was basically to simplify your monolithic applications. We started out with these big, complex applications where everything was built in to one code base, one compiled binary. And, you even run your database and all the services along with it, alongside it. Microservice breaks that down into different components. So maybe you had your authentication piece. You can break that out into an authentication microservice, and so on. Functions as a service takes that even a step further. So now every endpoint in your microservices might be a separate function. So the trend we're seeing here is that things are getting much smaller and smaller, much more simple. We're removing a lot of complexity as we go along. So why serverless from a developer point of view? Well, one, it's easier. You just think about your code. You don't have to think about infrastructure at all. It's faster to deploy, faster to iterate, faster to innovate. It's cheaper. You're only paying for while your code is running. You're not paying for while your code is sitting around waiting for a request to come in. So this can save a lot of money, especially on apps that may not be used 24/7. And it's powerful. Like I said, you get a lot of stuff built in, auto-scaling, management. All these things are built into the systems for you. So you don't have to rebuild them for every application you're building. Now, why serverless for a business? Well, the same advantages for the developer is the advantages for the business, because your developers can move faster, iterate faster, and not be held back by the complexities of a bigger application. And again, the cost reduction thing, you're only paying for execution, not for idle. So this will drastically reduce your operations costs. This even applies to private cloud. You get all the same advantages for your developers. If you went and set up an FN cluster on your private cloud, offered it to your engineers to develop on, they would get all the same benefits as running on a public cloud. They can iterate faster, innovate faster, deploy, and not worry about infrastructure. On the private cloud, you do have to manage, somebody or some team has to manage and operate the FN cluster, but the plus side here is that you only have to operate the FN cluster, because you can run a whole bunch of applications on one cluster. You don't have to deal with the different things that each different application needs. You just deal with one FN cluster your developers use it, and you don't really need to think about what each specific application. And it optimizes your hardware utilization, because now we can share the hardware to one of its most optimal states, and we'll go into that a little bit deeper. So typical application, you have one server means one app, or one VM, because your app needs to be available 24/7. It needs to be able to respond to requests when a request comes in. So whether that's apps being used or not, it's taking up resources 24/7. So as you can see here with this beautiful ASCII art, we have one server per app. Now in a serverless application, we can time slice and really optimize how we're using this hardware. So we can try to use the hardware all the time. And what that means is we can stick a whole bunch of different applications onto the same set of hardware, a smaller set of hardware, because we're using all the capacity we can. So as you can see here, or maybe you can't see here, it's maybe not that clear, but you have app 1 with a function, and it runs. As soon as it's done, we can stick a function from app 2 on it, and then app 3, and then app 4, all on the same servers. So we're really optimizing the hardware usage here, and that can drastically reduce your hardware costs. So now, what is the FN project? We just talked about serverless and the benefits of serverless. Now we'll get into the FN project. It's an open source serverless compute platform. It can be deployed to any cloud and on-premise. It's simple and extensible by design. Containers are the primitives. Now the bonus here is that you can write a function that can do anything. You can write it in any language. You can use whatever libraries you need, even whatever operating system you need if you want to get down to it. We have hot containers which provide fast response times. That basically keeps the containers alive. If you have an active function, it'll keep it alive for really fast response times. The community is very active with over 2,500 commits and 50 plus contributors. It's independently governed with plans for foundation, and it's Apache 2 license, so you can do whatever you want with it. Now let's look at it from a developer's perspective, how you would use FN. So an FN function is a small chunk of code wrapped into a container image. You get input via standard in and environment variables. You write output to standard out, and you log to standard error. Really going back to the primitives of a Unix operating system. And the FN server handles everything else. So when you're using the CLI, these would be your main commands that you'd use. FN init to generate some boilerplate code to get you started. You can choose your runtime. We support several different runtimes out of the box. This one's obviously using Java, and we're naming our function hello. And then FN run is how you run it locally and test it locally. FN test, I'll show you an example of this, but it's basically a way to define a bunch of inputs and outputs, and FN test will execute your function with those different inputs and compare it to the outputs so you can be sure your function working, you're not breaking it. FN deploy will deploy your function to a remote server or a local server. And FN call will call, similar to FN run, but it'll call your function on a remote server. Here's the details of FN deploy. So first thing it does is build your container and bumps the version. It automatically will do a multi-stage build if it's a supported language to make your function, your resulting function, as small as possible. Pushes the container to a registry, default Docker Hub, and then creates or updates the route on the FN server. And so you can see here we've deployed to an app called MyApp, and our function is called myfunc, and it's version 0.02. And every time we do a new deploy, that version will get bumped, so we always deploy the next version. We have a bunch of function development kits, FDKs we call them, in various languages: Python, Ruby, Java, Go, Node, and we're always trying to get more in there. The FDKs help you with parsing the input and writing the output. Gives you a nice developer experience, especially with hot functions where the where you basically have to loop on input. So it helps with the looping and just gives you a nice, you basically just have to implement a single function with a particular syntax. The syntax is familiar to Lambda developers for the languages that Lambda supports. You simply write a function that adheres to the FDK's interface, and it will parse the input and pass it in a nice object format, so you don't have to deal with any parsing issues. And same with the response. For debugging, we have a few commands. FN calls list. My app will list all of the recent requests or calls to your application. Then you can get more details on a particular call. If you call FN calls get my app with the call ID, and that'll return whether it was successful, whether it errored, how long it took, those types of things. And FN logs get will return the logs for that particular request. So you can check, for instance, for a call that failed or it was an error status, and find the log so you can debug it. We also include some metrics using open tracing and open census. And we have some plugins for Prometheus and others, so you can get all the metrics out that you need. There's a simple UI too that you can go run. This is also open source. It allows you to see your list of applications, set configuration, variables, some basic statistics there. Yeah. Now let's look at it from an operator's perspective. For a developer, it's easy. You write code, FN run, FN test, FN deploy, and boom, it's up and running somewhere. For the operations side of things, it's a little tricky. You actually have to deal with servers. So here's the high-level architecture. A request comes in, it hits the FNLB. Yes, we have a special load balancer, and I'll explain that in a minute. And then behind the load balancer is a bunch of FN servers. The FN servers are what actually execute functions, and you can scale those out as many as you want. So the more the merrier there. If you wanted to set up an auto scaling scheme, that's where you scale the FN servers, and that's where the actual functions will be executed. Behind that, we have several different services that are required. A database, obviously, for mapping your apps and your routes. Routes are basically your URLs to functions. There's a message queue for asynchronous activity. There's an asynchronous mode where you can queue up jobs for functions, and they'll run at some point in the future. There's an object store where we store logs and things to keep the database unused, and bigger things. Logs obviously can be a bigger storage item. And then a container registry. Any Docker registry can be used for that. Docker Hub is the default. Now the FN server, first of all, it handles the CRUD operations for setting up routes and functions. So as I was saying earlier, you can have /myfunction, and that points to function X, and with some configuration parameters if needed. If it needs to connect to a database or anything like that, you can have that passed in. It's also an API gateway, a simple API gateway. Again, so every function gets its own URL. It's easily addressable. And when a request comes in for that URL, it executes the function, returns the response to the client in HTTP format. If it's an asynchronous function call, it'll queue that up on the message queue. And asynchronous function calls get queued up, and they only run when there's capacity available, meaning the synchronous functions that come in through the API gateway or the HTTP requests will always run first because the user's waiting for them. The asynchronous ones will run when there's any available slots. The server's written in Go, and it's easy to extend via an extension system. If you want to plug in your own authentication system, you can do that. The FN load balancer. It's a simple, fast load balancer that routes functions to specific nodes, mostly because we have this hot function concept where the first time a request comes in for a function, it can stay running for a number of seconds, and if it keeps getting requests, the load balancer will send requests to that specific node. It also will scale functions. So this is where if a bunch of requests are coming in for a particular function and the one single server can't handle it, then the load balancer will say, well, I'm going to send it to 2 nodes. And if that can handle it, will say, I'm going to send it to 3 nodes, and so on. And also vice versa. If the traffic slows down, it'll start scaling it down. And this is how and where the functions scale independently. This is also where if you wanted to build an auto-scaling mechanism to launch new servers, you can use the FNLB since it's got a nice global view of the cluster. This is where you plug in and launch new servers if you need more capacity. This is similar to what I was just talking about in a nice diagram. So the request comes in at the top, hits the load balancer, and the load balancer will distribute the load nice and evenly to the available FN servers and auto-scale them, auto-scale each function, and return the response back. One of the other advantages of having the load balancer too is that not even just for hot containers, but if it sends it to the same servers over and over again, they'll also have the image cache, the Docker image cache, so you avoid the image pulls and things like that as well. Some of the supporting services, we have our database, message queue, blob store, which we just talked about. The default ones that are built in that work out of the box are MySQL, SQLite 3. If you want to just run on for local, the SQLite's nice. Postgres. For queues, we support Redis and Kafka. And registry, any Docker, V2 compliant, even private ones. Metrics, we're using Open Census for metrics and distributed tracing. Prometheus, we have a Prometheus plugin. And logging is via syslog, so you can send the logs to any log service that supports syslog, which most do. Here's an example of a Prometheus Dashboard. You can see how many are queued, how many functions are queued, how many are running, how many are completed, how many are failed. Those are your most common stats that come out of it. FN will also support the CNCF Cloud Event spec as a first-class messaging format, which means we'll accept it on the input all the way through into the functions themselves. So if the functions understand how to read the Cloud Event format, then they can read that format and respond all the way back out. This is very key to interoperability between different functions platforms. So we're really excited about this. All right, now for a quick little demo. So first thing I'm going to do is create a couple functions here. So there's nothing in this directory. I'll create a quick Go one. I'll create a few languages and show you, but. So fninet -- runtime go func. So let's see what that created. So I have 4 files here. The go package.toml, which is basically the Go dependencies, a func.go, a func.yaml, and a test.json. Let's look at func.go. So this is my Go code that was generated by the CLI. It's a good starting point. It's importing the Go FTK. This is the main function that gets run when a function gets called. We're just calling FTK.handle and my handler func. So this is the handler down here. You can see this. It's the correct syntax that the FTK expects. I have a context, I have an in-reader, and an outrider. So the first thing I'm going to do is I'm going to create this person object. You can see up here the person struct is just a name, just a struct with a name in it. And map to JSON is simply a JSON object with a name value. So I'm going to parse that with the JSON decode and make a response message, which will be either hello world, or if I got input with the name parameter, hello name. And then it just prints that out with this JSON new encoded out. So now I'm running fn run. This is building my brand new function and runs it fn, and I get a hello world. But if I do something like this, pass in some input, name Travis, and then fn run. Now it's building the image, and it'll pass in the thing. So now I have hello Travis. All right, so now you see that running. I passed an input, and the output changed. So let's look at some other files. We have a func.yaml file. This is all the languages you need a func.yaml file. As you can see here, I have a name, Go func, version, the runtime, Go, the entry point, which is essentially the image entry point, and the format of JSON, which is the default format for most of the FTKs. When you're using the FTK, you don't really need to think much about that format though. All right, so that's simply that. You can add more things here. There's a timeout parameter, how much memory it needs, things like that. There's also in here a test.json. So you can see here it's an array of inputs and outputs. So the first input, name, pass in Johnny. If I pass in that input, I expect it to say hello Johnny on the output. The second one, the body is empty, so I expect it to say hello world when there's no input. So now if I run fn test, it'll run both of those inputs and compare the outputs to make sure we're good. Now the cool thing about this is, test 1 pass, test 2 pass. The cool thing about this is it's language agnostic. So now if I go into my function and I change the language, or it's, you know, we're down the road, we need to do something else, but I can't break the contract that other people are expecting to use this function, I can go and do whatever I want with the container and run these tests and make sure that I'm not breaking anything. Now we can do the same thing with other languages. Let's try a simple Node one. This is Node func. Again, got similar files here. Oops, fn run. Builds my function. And same thing. So we can do the same thing here. Now how about a Java one? Runtime Java func. And again, we got this. The Java one's obviously it lays it out in a. Oops, let's go to the Java func. If I do the tree here, see it's laid out in a typical Java fashion, what you'd expect. So now if I cat the source on this one, see it's very simple. You know, what is this, 10 lines of code, if that? It's a function class, has a handle request method in it, and that method is very similar to the other ones, hello world or hello name, depending on the input. The Java one Has some nice coercion too. If instead of if that string input were some object input, it would try to coerce the input into object format. So it's got some nice Java-like features in it. But again, fn run here builds my Java function and runs it. I can do the same echo type thing. This one doesn't take JSON, it just takes string, fn run. You can see it says hello Travis. Now I'm going to go back to the Go function. I'm going to deploy this for you. Well, first of all, let's go over here. I'm just going to start up a local FN server. So I simply just do FN start. And we can see that running over here. So if I do an FN deploy, demo app, --app, demo app. Now this is going to build my function. Bumps the version, going to push it to Docker registry. This is Docker Hub. And then finally update the URL. So now it should be running on the server, so I could do a curl localhost 8080 /r/demo app /go_func is what it's called. And you can see, we hit our little Go function. It says hello world. There's also some nice CLI features for this. I can do fn call demo app go func, similar to curl, except you can do cool things like this. Echo. I can pipe input to a remote fn server as if it were a local running container. Fn call demo app go func, and boom. I just piped input to a remote API call. The function ran and returned the response. Just to show that a little bit more, we can go to localhost 8080 demo app go func, and you can see got the same response there. And so that's how it would work. That's how the localhost experience, that's exactly how it would work if you were deploying to a cloud. Let's say you wanted to deploy this to Oracle Cloud. You would just you'd set up the Oracle Cloud configuration and fn deploy. And you'd have your function running on the cloud. So that's the quick demo of use. Very simple, as you can see. And yeah. You can go find the project at github.com/fnproject/fn. Please start if you go there. Join the conversation. We have an open Slack that anybody can join. If you have any questions, slack.fnproject.io. Go to our website, fnproject.io. And we're hiring. Email me or tweet me. I'm at treader on Twitter, or email me at travis.reader@oracle.com. I hope this was useful. Thank you for watching and listening.